Now our sample is all set here. As I said, there is a gap which the program is going to fill the gap. Now what we're going to do, we're going to go to the software that is called unconfined UC software. This is software. And the first thing you do, as usual, you go to File, Load, and you load a template, either this template or a previously run test. So you got all the information here. You can update the information about the date. You need to enter, you go to specimen, you need to enter the exact diameter of the sample and say 142, the weight of the sample, say 150 grams, specific gravity. You need to enter if you have water content, your read table, how you're going to record the data. The test parameter, this is a read table that corresponds to that. So we're going to pick strain. Strain rate is 1% per minute. Automatically the program computes the percent per minute because this is the standard from the ASTM standard, and other standards is running really fast, 1% minute. That means in 15 minutes the test is over. Those are the criteria that will stop the test. Either the maximum duration is reached, or the maximum duration after peak load, or the ratio between load to the peak, or the maximum load, which you have your load cell, or the maximum displacement. Now what we're going to do, we're going to go to View, System. We're going to look at our load, our displacement, the power. Again, we're going to do the check, make sure that everything is communicating. The load here is showing 1 Newton. I can go to Calibrate, Summary, and I change my offset to 32856. This value is the same as this value, and I do Apply, I do OK. My load now is 0. I go to View, Channel, Load, View, Engineering, and I can check, I can push on my load cell, and I should see 100 by hand. I could see 100 Newton. That just tells me that the calibration factor is correct. And I can also check my displacement by inserting a gauge. And I should see the displacement sensor, which is underneath here. And I can see how much is changing. I can put a gauge and I can check that. So that's just a quick check. The next thing I'm going to do is I go to Run, do Start. I give it a different name, always different name. Do Save. And you're going to get a message saying Position Platen. You say yes. And then you wait. The platen now is being positioned to close the gap between the top cap, and there's a gap here. If you have a piece of paper, you can insert a piece of paper that there is a gap. Now the software automatically closes the gap, so your test starts from beginning. So if you take a piece of paper here, you can see there is a gap. So what the software now is doing, the platen is moving very slowly to close the gap. If you press down on it, it will go faster. And as you can tell, there is still a gap there. There's a gap. We're trying to close the gap. Once the gap is closed, the light will go off and will stop. That means, and there's a small load, like a seeding load on the sample. So the gap is almost closing here. I'm just accelerating the process. So now the gap is closed. I can put my piece of paper, and this light stops. Then I go to my program and I say OK. and the test start to run automatically from beginning till the end. I can do view, test monitor, view test graph, and I can see my graph. And the test is running, the motor is moving up, and it's keeping track of the loads, stresses, displacement, everything I need. Until the end, whatever criteria comes first, and then it will automatically stop. The test is finished, the criteria is met, sample has failed. What I do OK. Now I go to control, load, and I put 0, and I do go. So the load is going to decrease here till 0. That will allow me to take the sample out when the load is 0. So I wait, the motor is going down. And now I can take my sample and make my measurements, and the test is done. Okay?